Alrighty, so just to let you all know, this webinar is going to be recorded for your further review, and it'll be archived online, and we can go ahead and start that recording now. Welcome everyone to Performing Statistical Tests with FCS Express. My name is Kaya Ghosh. I'm a Technical Application Specialist for Novo software. And what I'd like to do today is give you an overview of all the statistical tests that you can do in FCS Express. So we'll kind of look at our manual reference page and just run through all the different tests that are available to you so you're aware of the capabilities within the software. Of course, we're not going to have time to do an example of every single test today. So what I did is I picked two very interesting and probably really useful examples of statistical tests that you might want to perform on your flow or image cytometry data in FCS Express. Okay, so what we'll do is we'll look at some either completely built or partially built layouts, and we'll go over how to set up those statistical tests and how to display the results in a bar plot or tables or whatever it is that you want to do. And again, during the course of the webinar, please do feel free to enter your questions into the questions and answer box here in the lower right corner of the layout, because we want to make sure that you're understanding everything we're talking about, and if there's a little uncertainty, we're going to try our best to clear that up for you right away so you can keep up with the webinar. So please don't be shy about doing that. So just a little outline of what we'll be talking about today. What I'm hoping to convince you that it's going to save you a lot of time and just a lot of effort over the long run to do your statistical tests in FCS Express. So we have a wide variety of statistical tests, and I'll show you a laundry list of those in a moment. But the really key advantage of doing all your tests in FCS Express rather than exporting your MFIs and your means and everything like that to Excel and then taking that to Prism or SPSS or whatever it is that you do your statistical analysis in, it's a lot better to do all that within FCS Express, because as you'll see in a moment, all of the results are going to update in real time as you change your data or as you adjust your gates and markers and plots. So once you build your layout as a template, basically there's going to be no additional work every time you repeat your experiment. So there's going to be no recreating the wheel, no re-exporting to Excel every time you nudge your gates this way or that. And the power of the statistical test is built into FCS Express that way. All right, so what we'll do today is we're going to talk about two examples, like I mentioned. The first example we're going to talk about is the t-test, and I have a nice layout that's almost completely built to show you how that works. And the second example is we're going to talk about the ZFactor test. Okay, before I get more into detail here, I just want to show you a quick list of all the tests that are actually available to you in FCS Express. So if you go to the help resources, if you ever want to refer to this later, and just click on help and manual, or if you go to file tab help from within the software, you will come to our help and manual, that looks like this. And then from there you can search for any kind of test you're looking for, like a t-test, or whatever it is. But the key page you want to refer to here is the custom token formula reference. And that's another thing that you can write to us if you're just having trouble finding that page. Just send us a quick email at support and we'll be able to refer you to the page here that has the list of tests that are available. But in a nutshell, these are all the tests. And so I would group these into a few categories. And some of them are tests for goodness of fit. Some of them are tests for significance. Others are tests for the variation between samples, or variation between your observed data set versus your expected data. Others are a test of the suitability of your assay for scale-up to, for instance, high-throughput screens. So we've got 3 or 4 broad categories of statistical tests you can choose from. So we do have a chi-square test. I just want to point out that that's the goodness of fit chi-square. It's not the chi-square based on contingency tables that some of you might be thinking about. But if that's something that would be useful to you, please send us an email at support@denovosoftware.com, because we want to hear what it is that our customers really want to use. And we're adding new tests and new formulas all the time. Some of you who are familiar with earlier versions of FCS Express or with the regressions in FCS Express, you might know that we have upwards of several dozen regression formulas already, and those are pretty trivial for us to put in. So if there's something you really want to see, we want to hear from you, so definitely write to us. So the chi-square test, goodness of fit, we've got the F test to compare sample variances. Let me switch to my pen here. We've got the Grubbs test for outliers. Let's see, Mann-Whitney, T-tests, Wilcoxon. These are all tests for significance, as you might be aware. We also have the stain index. If you want to evaluate the fluorophore staining, the relative brightness of different fluorophores, and that's something you would do in the course of your assay design when you want to, for instance, choose antibodies or evaluate the performance of a test on a new cytometer or different settings on the cytometer. So that's something that we put in relatively recently. We also have SSMD here and the Z prime. So these are 2 examples of tests that you would use to evaluate the suitability of an assay for scale up, okay? And so today what we're going to do is we're going to focus on 2 of them, like I mentioned. So we're going to focus on, let me see if I can zoom out here. Oops, that's a little too much. Okay, so we're going to focus on the Z prime and also the basic t-test. Okay, so again, if you guys have any questions or comments at this point, please go ahead and enter them into the questions and answer box. And just for folks who, I noticed we've had a few people log on a couple minutes late, I just wanted to take a moment to point that out again. So if you come over here to, usually it's in the lower right corner of your screen, you'll see a questions and answer box. And you can just enter your questions in here, and we'll be able to answer you either during the course of the webinar, or my colleague on the line will be able to answer you. Alrighty, so why don't we go back to the webinar outline here, and we're going to talk about 2 different examples of statistical tests in FCS Express. Okay, and the first one here is the t-test example. And so we have a layout that's actually completely built, and it basically has a number of replicates comparing different treatment conditions, treatment times actually, and it's tracking the change in different populations over time. And there's replicates, so most of the samples are acquired in triplicate. And so we've set up a spreadsheet, which you'll see is sort of like a mini Excel spreadsheet in FCS Express. And in that spreadsheet, we have the means and the standard deviations of all the replicates. And we've set up a bar plot to graph the means and standard deviations as basically error bars on the bar plot rather. And then we've also set up a t-test to calculate the p-value, or the significance, the difference between those different treatment conditions. Okay, and after that we will take a look at the ZFactor example. Okay, and that one's completely built. All right, so why don't I go ahead and show you what we're aiming to do here. So this is the completely built layout, and we're going to build all of the statistical elements from scratch together, so you'll see an example of how this works. But just to explain the overall idea of this layout, basically we are comparing the change in different gates over time. So if you take a look at the bar plot here, we are looking at lymphs in red, green, the granulocytes are the green bars, and the monocytes are the purple bars. And we're looking at 3 different treatment times. So we're looking at the 0-hour time point of treatment, 6 hours, and the 12 hours. Okay, and we've graphed the means versus the means of the standard Ds as the error bars with replicates. Okay, so, and if you take a look at the way the layout is built, the bar plots are color-coded to the gate colors. So the green are the granulocytes, the purple are the monocytes, and the red are the limbs, just like on the bar plot for convenience. All right, and we've got our 0-hour time point up here at the top. Okay, and if you take a look at this layout, at these 2 plots, these gates we've set up as linked. So if I move the granulocyte gate around, both of those move at the same time. Okay, these in the middle, these are our 6-hour replicates, and those required in triplicate. And these are our 12-hour replicates, also acquired in triplicate. Okay, the way this has been set up is we have data-specific gates on all of these, so you can move these gates around individually without affecting the other samples. Okay, but that's something that you would be able to decide as an experimenter what's appropriate. Do you want all the gates to move in concert, or do you want to have the flexibility to shape the gate around individual populations? That's completely up to you, and you can decide what's scientifically appropriate for your assay. Okay, since this is kind of a specialized webinar, I'm not going to talk about how we actually started building the layout. I'm not going to go into like building plots and creating gates and how to put in you know, basic statistics or formatting elements, because we're going to assume that you either have some knowledge of that or you would be able to refer to another webinar or a manual page about that. But just to quickly make one note, I did want to mention that for those of you who are already doing flow cytometry batch processing in FCS Express, typically when you're doing example like layout like this, where you're testing for significance or doing some kind of statistical comparison among samples, this is typically not necessarily a layout that you would batch process, unless you have, you know, multiple instances of comparisons. So basically you have to have the plots side by side on the layout for all of the comparisons that you want to make. So for this example, since I'm comparing my 0-hour to my 6-hour, and I'm also comparing my 0-hour to my 12-hour down here, I have to have all of these showing on the layout at the same time. Okay, so because the bar plot and these regression plots down here are actually deriving those values from the plots themselves. Okay, so you know, you could batch process through it if I had, let's say I had, rather than just 8 files, I had, you know, 16 files, and I'd want to batch through, you know, the next iteration of this group of 8 plots. Of course, you could batch process in that sense, but the comparisons you're making, they all have to be present as plots on the page, if that makes sense, okay? And if you've gone through a lot of painstaking formatting, it's really easy to apply that formatting to new files on your layout. A quick shortcut I'll show you is you can just highlight a plot and do a Control-D. And you see now I've got all the formatting elements, and then you can just drag the next file from your data list onto the plot, and you see that it got replaced. Okay, so that's like a nice way to quickly build these layouts. Another thing you can do is you can even highlight a bunch of plots, do a Control-C, and then you could come and just paste it in using the clipboard. Okay, so it's actually quite easy to build a very complex layout. Alrighty, so any questions at this point? I do see a couple, and I think most of those look like they've been answered through our chat window. All right, so another thing, besides the bar plot itself on this layout, we also have this table right here, and I actually cannot maximize that, so let me just zoom in here. So this table that we have is showing in each row we've got a different treatment time, so 0 hours, and then this is the 6 hours, this is the 12 hours, And we've got the 3 gates, also color-coded in columns here, lymphs, grans, and monos. And the first sub-column is the percent gated plus or minus the standard dev, which is, by the way, the error bars. And then in the right sub-column for each of the gates, we have the p-value with the number of asterisks. And that's based on the t-test. So how is this all set up? And we also have regression plots. Sorry, there's so many things going on in this layout. I have to make sure I tell you about all of them. But you'll see that they're all kind of based on the same mini spreadsheet. So it's super easy to build this. But here at the bottom, we have some scatter with regression plots. We have one for each gate. So the red is the lymphs, the green is the grans, the purple is the monos. And we're basically graphing the percent gated on the y-axis versus treatment time on the x-axis. And we are calculating the change in percent gated per hour. And that's based on a linear regression that's been applied to the plot. So this line, you could probably tell, it's not merely a connecting line between dots, it's actually a linear regression. And of course, we could get as fancy as you want. If you want a nonlinear regression, we can do that too. Okay, so let's get started. So you're probably thinking this is all well and good, but what does this actually do for you? So the key advantage here is that once you build your template, you can load your data over and over into it every time you do a repetition of the same experiment, and your bar plots and p-values and everything will auto-calculate. The other nice thing is you can watch that these values are going to auto-calculate even when I move the gates. So let's see, when I move my granulocytes gate, keep an eye on the asterisk for the significance above the 6-hour treatment bar, the green bar. Now when I move the granulocytes gate, you see that the controls bar is changing and it's getting closer to the value of the 6-hour treatment bar. And you can see that the asterisk disappeared because it's no longer significant. Okay, and now I'm going to move it back, and it's back. I can move also the gates down here on the 6-hour treatment, for example. In this case, I'm going to move the lymphs gate, so keep an eye on this bar right here and the number of asterisks. Okay, so when I move my lymphs gate, and you see, I'm basically moving it so that my error bar gets a little tighter, and you see how the significance has increased to the level of 3 asterisks, which I think we've defined as 0.001. Okay, of course, if I move this so that the error bar, the standard dev, is really wide, there's no significance at all. Okay, and same down here. So I can set up these gates as I want as well. And you can see that these are also updating in real time. Okay, and again, the 6-hour and 12-hour replicates, they were set up intentionally as data-specific gates so that they can be moved independently, whereas the controls were set up as regular gates, which are linked by default in FCS Express. So these two, the duplicate controls, they're moving in concert with each other, okay? But you could certainly set those up as data-specific if you wanted to. That's completely up to you. Okay, any questions before we talk about how this was actually built? All right, so if I come to page 2, we can look at the spreadsheet that the bar plot and the regressions are based on. So this spreadsheet looks just like an Excel spreadsheet. Okay, and so what we've done is we've set up one row for each treatment time, 0 hours, 6 hour, 12 hour. And then we have one column for each of the stats that we need to calculate our graph. So we have these 5 columns are for the lymphs. And I've got replicate 1, replicate 2, replicate 3, and then a column for the mean of the replicates. And then I have this column for the standard dev of the replicates. Okay, and I basically have the same setup for the granulocytes and the same setup for the monocytes. Okay, and so the advantage here of doing all this in FCS Express is everything's going to update. So watch what happens when for instance, keep your eye on the lymphs mean. Just when I move this this around. You see that the limps mean in row 2, which corresponds to the 0-hour controls, that's moving around, right? So if you were to do this in whatever software you're using, whether it's FCS Express or another flow package, you would have to, every time you nudge these gates around, you would have to re-export to Excel and rebuild your bar plots in Excel, or take that data from Excel and do a paste or paste transpose in Prism. Or SPSS. Sometimes those programs have very specific formats about the confirmation of the data. And so that can be really tedious, right? Because in reality, your samples are going to change from day to day, and you probably do have to move the gates around. Or maybe you're doing a different kind of assay with a different cell line, then of course your gates are going to change. And so why recreate the wheel every time you do a variation on what you've already done? So this is all changing in real time. And so if I click on any one of these, you see that it's actually not a free text value, it's referring to a token. And for those of you who are already familiar with the concept of tokens and statistics in FCS Express, I can show you that you can right-click on any of these and see exactly what plot that statistic is coming from. So that statistic, limps rep 1, is coming from plot 91. We've got a thumbnail of it right here, and then we can come to the statistics pane and see that it's a statistic based off of the limps gate, and it's the percent of gated cells specifically. Okay, and then these limps means and standard deviations, that works just like Excel. So it's basically the average of those cells, I'm sorry. And then this is the standard deviation of those cells. So I think this is going to be pretty straightforward for most of you, because I know that for the most part, you guys have spent hours and hours of doing things like this in Excel. So it should be pretty easy to figure out or to get accustomed to doing this in FCS Express. So without further ado, let's actually get started. I want to show you how you can build this yourself and how you can put in the p-values. Okay, here we go. So the first thing we're going to do is we're going to put in that spreadsheet. And that is up here on the Insert tab, and it's under Spreadsheet. So, and I'll give this a name, call it my spreadsheet for bar plot and p-values. Okay, and now we can give each of our columns different names. So this will be our treatment time. And this will be our limps, rep 1, limps, oops, rep 2, limps, rep 3, and we will do our monos, rep 1, oops, monos. Oh, let me go in the order that I've actually have it displaying the table down below, just so I don't confuse myself. So grands rep 1, grands rep 2, grands rep 3. Okay, and lastly we have the monos. Monos rep 3. Okay. So let's put in our treatment time, and this I'm going to enter in as free text, but if you did have keywords, you could enter it in as a keyword simply by dragging the plot, the relevant plot, into the cell and choose keyword. And for those of you who don't know, keywords are the metadata that you entered in at the time of acquisition. And if you did have that treatment time as a keyword, it would probably be down towards the bottom of the user entered keywords, and you could enter that in just by clicking there. Okay, I actually don't have that info as keywords, so I'm just going to enter it in free text. And here is where we are going to, enter in the statistics based off of the plots themselves. And this is very simple. If some of you are already used to doing this with our batch export to Excel, you already know how to drag gates over or even if you're used to dragging it into tables, you already know how to do that. So let's go ahead and drag our lymphs rep 1 into the appropriate cell here. Okay, so the software, you can see it already knows that I want something based off of lymphs right here. I don't have to select that. So just select % of gated cells, and I'm going to grab this one and drag that over. And again, % of gated cells. So I'm going to go ahead and do this really kind of quickly. And that way you'll see that if you just put a little bit of thought into designing your spreadsheet, the actual filling of the spreadsheet is fairly trivial. So I'm on my 12-hour replicates of lymphs now. Okay, let me show you another kind of cool trick that you can do. So I've already filled in like the full complement of, of statistics for all of the lymphs. Oh, whoops, I forgot to put in columns for the means. Let me put that in. But actually I'm glad, because that gives me a chance to show you. If you forget to put in a column, like I did for the means and the standard devs, you could insert a column just like you would in Excel. Just come to Spreadsheet, Layout, and go Insert Column. I'm actually going to put in 2 here. Call that lymphs standard, lymphs mean, and this one is lymphs standard dev. Okay, and I will come over here and do the same thing for my grands. Okay, and lastly, of course, we need to do that for the monos. All right. Okay, so let me show you the cool trick. Rather than dragging the monos, or in this case, I guess we'll do the green grands next, rather than dragging the green grand gate over to the columns, I'm just going to do a quick copy paste. I'll do a Control-C, come over into the appropriate cell under grands replicate 1, do a Control-V, and now I can just go in here and change the gate for all of these. Okay, so I'm just going to go right-click, Format Token, and change this to my grands. And I'm just going to quickly go ahead and do that for all of these statistics in this section. And I believe we have had customers ask for a batch edit. So we don't have that right now, but that is on our radar in case that was the question on your lips. But hopefully this is not too hard to do. So I'm just going on here and I'm changing all of these, because basically the plots are the same, the statistic % of gated cells is the same. I just need to change the gate for all of them. And that's why it's fairly straightforward to just do that one by one. Okay, and I'm going to go ahead and do that for the monos as well. So we'll go paste, and I will reformat these. Okay, I'm getting there. The cool part's coming, I promise. I just wanted to go through the very beginning of building this with you, so you'll see that I have nothing up my sleeve. So thanks for sitting through this with me. So keep in mind, you would have to make sure that these are all exported into Excel in the correct column as well. So you're either going to be dragging these to your Excel export or doing it right here in the layout. So there's some work. I would think there's some work associated with it either way. Okay, so let's go ahead and put in our means. So this is pretty simple here. we're going to type an equal sign. And this looks a lot like it would in Excel. So you could either just write out the word average, like you might be doing in Excel, or come to our formulas tab and put in the average formula, and then just drag your cursor to select the cells and hit return. Okay, I can do a column fill here. Well, let me actually wait and let me put in the standard div now to the error bars column. Okay, and I'm going to select these two guys right here. Okay, and now I can just do a column fill here to fill in those results for the other treatment times, the 6-hour and the 12-hour. Okay, now same thing here. I'm going to come over here and just say this equals average. Whoops. And I'm going to grab these. And you can also do a Control-C, Control-V here, and you can write the, hopefully I'm going to get the syntax right, standard div.s, okay. That's why I like to use the drop-down menus, just so I know I'm doing it correctly, but you can type it in just like you can in Excel. Okay, so there are those. And let me quickly fill that in here. See, that time I typed it free text. And then this is okay. Okay, so now I'm going to do my column fill again, my favorite thing to do in spreadsheets. Alrighty, so now we're ready to put in our bar plot. And I realize this is a webinar about statistical tests, not about bar plots, but usually when you're doing t-tests and p-values, you usually do want to look at a bar plot. So I figured it's all quite related, so I wanted to show you the whole 9 yards. So to put in your bar plot, it's quite trivial. Just make sure that spreadsheet is selected by clicking on it. Come over into your Insert tab and put in your bar plot from here. So you can click bar and drag it to the size that you want it to be. Okay, and we just need to format the spreadsheet to derive the axis titles from the top column, the top row of the spreadsheet. So we don't do that by default, but you can come in here and right-click Format. And we will just check off this box to use the values in the first row as labels. Okay, and so now you see the bar plot down here has defaulted to the label for A, and it's defaulted to the B column for the y-axis, which is not what we want. We want it to actually show column E, the lengths mean. Okay, so I'm going to just click on the axis and change this to lengths mean. There we go. All right, now how do we put in the error bars? So those of you who already know about FCS Express, you can right-click on any plot and go to Format there in the pop-up menu and change the axis titles, etc. Overlays. Okay, so it's the same thing with a bar plot. You right-click, Format, and we'll come over here to Overlays, and we're going to put in our error bars right here. Okay, so right now it is not showing any error bar at all, and we just need to tell it what column to get the error bars from, because it's not psychic, so you would have to tell Excel also, right? So we're going to tell it to get it from column F. Or in my case, I've titled my column, so I can just go straight to lengths standard div. Okay, and now I have my error bars there on the bar plot. I like to make the layout look nice and make it kind of correspond to my gate colors, especially when I have a lot of things going on in the layout. That's totally optional, but just to mention, since we're here, this is where you would do it. So I'm going to change my bar color to red. I'll also change my error bar color to red. You can change the error bar thickness. You can make it dotted. whatever you want. Okay? And just a quick note, you can change the font of your title, all those typical things that you would want to do, they're here. Okay? All right, so your next question is, well, how do I graph my overlays? Because remember, the layout I originally showed you had bar plot overlays. So that's just like graphing overlays in FCS Express. So, you know, in FCS Express with regular plots, let's say you have a histogram, just to show you real quick. So let's say we have a histogram here. If you want to make overlays, you just grab you know, one or multiple files, drag them over, and say add. Okay. Of course, these two look relatively the same. Okay, so now we see some differences, right? So let's go ahead and do the same thing. So to make an overlay in a bar plot, just grab the spreadsheet, drag it into the bar plot, and select the second option, just like you would if you were making a histogram overlay. Say OK. Okay, and now I'm going to right-click. It actually is showing two bars now. That's why the bar looks kind of thick and the error bar is to the left. So let's right-click Format, and let's tell the bar plot where to get the second overlay. So I'm going to click on my second overlay here. Okay, and we're going to change the bar to come from the grand's mean, and the error bars should come from the grand standard dev. And I'll change the bar color to match. It's going to be green. Let's change these to green as well. Okay, so that is that. So, and let me quickly, just for the sake of completion, although I think you get the idea, I'm going to just quickly add in the monos as well. And again, I need to right-click Format and tell the software to get the third overlay from the monos mean and the error bars from the mono standard dev. Whoops. And I'll give it that purple color so it matches. Okay, and the legend. All right, so not to spend too much time on the bar plot, but just wanted to put that in for you. Okay. And of course, let me come over here and type these in. So you could also put in keywords here if these were keywords as well. All right, so how do we set up, so that's our bar plot, right? Now, how do we set up the test for significance? So I would suggest setting up the test for significance in our custom tokens window. That's usually the easiest way to do it. So you can come over here to view and come into your custom tokens. Okay, and I think I've already set up a few of these. That's why this table is partially filled. So let's just set up the one for the monos 12 hour. And so in each case, the hour time points are being compared to the 0 time point. Okay, so we're going to put in a new custom token. And I'm going to call this T-tests monos 12 hour. Okay, and now you can right click and go to this menu, and you want to go into the statistics submenu and put in, we have two different basic t-tests. So we have the 1S and the 2S. I believe what we're using here is the 2S. Let me double check. Yeah. Okay. So here what we're going to do is put in the numbers for the 12 hour. And then compare that to the numbers, which is going to be all of the replicate values from the 0 hour. Okay, so this is again just by dragging and dropping, so we can put in actually, you know, I think it's easiest if you just drag and drop the gates in. So we will put in our what do we got? Monos. Okay, so we'll put in our monos here and say % of gated cells. Oops. Sorry. I'll grab this one now. Okay, and now we will do the same thing here, and I'm going to grab from the 12 hours this time. So you could actually use tokens from your spreadsheet as well. That's another option for you. Just to show you how that works, you could just go right-click, insert token, and insert the spreadsheet cell value. Okay, and you see that we have something at the end for the other t-tests that have already been built. We have some of the syntax built in here, and so the number of tails we're going to put in 2 because we don't know which way. We're not doing a unidirectional t-test because we don't know which way the difference is going. So we're going to define it as checking for significance in both directions, whether the 0 hour is less or more than the 12 hour. And paired, in our case, these are not paired observations, so we're putting in false. So paired would be like, you know, if you have mouse 1 and you have mouse 1, mouse 2, mouse 3, and you're checking from that specific mouse at 0 and 12 hours, but we don't have that situation, so they're not paired. So then you can grab this and put this p-value directly into the text table that you made, okay? And we also have some asterisks. So the asterisks don't auto-display, although I'm making a suggestion to do that. So I've just sort of set that up as custom tokens, which is an if-then statement. So we're basically saying if the t-test value is between 0.1 and 0.05, then display 1 asterisk. If it's between these 2 values, then 2. If it's between 0 and 0.01, then we would say it's 3. Okay, and then you can, of course, grab these and put them onto the bar plot. Okay, so looks like I might have undid that. There we go. Okay, so any questions? So you can see that this p-value here in the lower right cell in my table, that's updating when I move my monos around, okay? I can also move the control around, and it's updating as well. Okay, so, you know, keep in mind, I really think this is going to save you some time. So it did take us, I kind of talked a lot at the beginning of the webinar, but I don't think this took us more than 15 or 20 minutes to set up an FCS Express. And now you can reuse it at the drop of a hat every time you redo it. And based on this spreadsheet that you have, you can even quickly put in those regression plots like I showed you, which is sort of icing on the cake. So we have these regression plots at the bottom showing the quantitative change over time, and we can put that in a jiffy just by, again, clicking on the spreadsheet, putting in my scatter with regression. Okay, and again, I'm going to change this to, let's look at something different. Let's look at our monos mean. Okay, and again, we're just going to right-click format and come in and put in our standard D there. Okay, I see a question asking about ANOVA being more appropriate. So ANOVA and chi-square tests, yeah, you're right. You can do that if you're looking for a difference between like the whole group of treatments. Like, is there a general difference for treatment time in general, 0, 6, or 12? But in a lot of cases, you really just want to compare each treatment time to the 0 treatment time. So since we're just doing a pairwise combination comparison in this time, we're just asking, is the treatment time of 6 significantly different than 0? And is the treatment time of 12 significantly different than 0? In this case, this was more appropriate. Perhaps the experimenter was looking for, does this drug have an effect at all? And they don't even know which treatment time is going to be significant relative to 0. But it's absolutely up to you. Yeah, in some cases, an ANOVA or chi-square might be more appropriate. And that's really depends on the goals of the experiment. All right, so any other questions about this layout before we quickly move on to an example of a high throughput screen pilot study? And there was a second follow-up to the question, what do we know about, I believe, if the samples are normally distributed? So yes, the basic t-test does assume a more or less normal distribution, but we do have other kinds of significant tests built into FCS Express, such as the Mann-Whitney. And I don't want to give too much advice just because you might want to contact your biostatisticians or read some references if you have any doubts. But in general, the Mann-Whitney is one test that's referred to for non-normal distributions. Okay? And we also have the Wilcoxon, which is similar to the Mann-Whitney, but that's often used for matched or dependent samples. Alrighty, so thanks so much for sticking with me so far. We've done a lot in just a short amount of time. So I'm going to go ahead and I'll leave this open in case questions arise, but I'm going to open up the other layout. Oh, before I do that, let's talk about what we're going to actually do in the other layout. So we are coming up on about 48 minutes. So I'm not going to build anything in the ZFactor layout, but we're going to talk a little bit about it. So it just gives you some food for thought about things that might be useful for you. So the ZFactor is a statistical test that's been suggested for evaluating whether a pilot assay gives appropriate results, or if it's an appropriate assay, that it really justifies scaling up to a true high throughput scale. Okay, so in short, there's a number of scholarly references about Z-tests, but basically it's looking at, you'll get a higher Z-factor, and the Z-factor is always a maximum of 1. So the higher the Z-factor is, the closer it is to 1, the better the spread is between your positive and negative controls. Well, the bigger the difference is, and the smaller the spread between for each of those controls. So ideally, you want to have a really narrowly distributed positive control, a really narrowly distributed negative control, and you want to have as wide a possible difference between them. So the maximum value there would be 1. So like a really large difference between the two with a narrow spread, narrow overlap, that's going to give you a Z-factor of 1. Okay, so we're going to look at a pre-built layout of a multi-well plate experiment. And it's a pilot study for a drug screen. And we'll use the Z-factor formula, which has already been set up in the custom tokens like I showed you, to determine the suitability of the assay for the high throughput scale up. All right, so let's open that up. Okay, and so this actually shows you a little bit of what I was saying. This is a nice paper to refer to. I have the reference down here. It's a paper from 1999. And it talks about the Z-factor, and I believe, yeah, this one just talks about the Z-factor. And there's other papers out there that discuss the Z-factor versus FSMD, which we also have. But basically, this shows the values that you want. So 1 is an ideal assay. Anything above 0.5, it's telling you that the separation band is large, so that's still considered quite good. You know, as the value declines, of course, the power of the assay decreases. So it's not that if it's between 0 and 0.5, it's unacceptable, but it's not as good. Anything less than 0 is, according to this statistical model, is unacceptable or not appropriate for your screen. Okay, so without getting too much into the nitty-gritty of what's going on in this layout, I just want to give you a quick idea of the type of layout that this is. So this is a drug screen layout where we have multiple different drugs. In green at the bottom here, we have compound 1. In pink or mauve, we have another compound. I'm sorry, the green is a number of concentrated controls. The pink is compound 1 and the blue is compound 2. And then we have a couple of different controls here. So we have the negative control in purple. This would be, these two wells are our negative control, just DMSO alone, solvent alone. Okay, and these down here, these are our positive controls. It's 500 nanomolar, excuse me, of a drug with known activity that can be used as a positive control. Okay, so this assay is, it's a multiple plate assay, but it hasn't been scaled up to really high throughput yet because the experimenter is just running it as a pilot to figure out if his assay conditions are appropriate. Does give him a proper negative control versus positive control statistical distribution to justify scale up. So there's a whole lot of things going on here. There's all kinds of gates. There's even some QC pages, which is based on the number of counts per well. So it's getting a little far afield from the subject of today's webinar, but I just want you to be aware of the capabilities. You can automatically exclude wells that have too few cells or too few events or too much background, anything you want. And it's actually imaging data, another cool thing to point out, but the principles are the same for flow alone data. So basically, let's take a look at this histogram down here. So we have the black histogram overlay, which is our negative control, DMSO control. And then we have the red overlay, which is our 500 nanomolar positive control. Okay, and the Z-score has already been set up, and it's here in my custom tokens. Just so you know, though, although I did show you how to do this in custom tokens, a lot of these formulas are here in the spreadsheet. So if you feel more comfortable or it's just more convenient for you to use it in the spreadsheet, you can certainly do that. So if I come down to statistical, trying to speed up my scroll here a little bit. So our t-test is there too. I could have shown you how to do that in the spreadsheet. And the Z prime is here as well. Okay, but this has already just been set up in the custom token. So we're just going to look at it real quick. So if I just put in a new one, I just want you to see the syntax here. I'm not going to actually build this. Okay, so here's the syntax. So all you need is the mean of the negative population, the standard dev of the negative, and then the mean of the positive and the standard dev of the positive. Okay, and the formula is actually quite simple. I think I had it on the welcome screen, but there's many references online if you want to check what the actual formula is. But those are the 4 stats you need. It's pretty simple, pretty straightforward, and I think that's what's lended to the popularity of this particular statistic as an evaluation statistic for your assay. So it's already been built and it's already been filled in here, but what this is doing is taking the median for the histogram of the DMSO. So that's this value right here. Let me use my pen. Okay, so this value is the median for M2, the DMSO marker, and the standard dev of the same marker. Okay, and then we have the median for the positive control and the standard dev for the positive control. Okay, and I can even change this if you'd like to see what the actual values are. I'm just going to change the display mode of these tokens so you see that the values that we're looking at. And since this is calculating on the markers, I can move the markers around, resize them. You see that the Z-score is updating. And it's completely up to you. You're the experimenter, so you know what the appropriate marker placement is. You could even link these markers together so that one moves and the other moves in concert. You can even get really fancy and define the bounds or the medians of these markers based on another plot, like if you have another control plot. So it can be as subjective or as objective as you want it to be. And you can also change the gates. So right now, these histograms are based on the negative control and the positive control gates based on the heat map layout plan. So we can look at, for instance, our DMSO control wells, and look what happens if I edit it. Let's say that I think that these two wells didn't have enough cells, so I'm going to take them out of the well. You see my Z value, my Z score changed. Okay, it's changing all the time. Okay, let's put those back in. Same thing with my positive control wells. So let's check out our all DMSO control wells. That's what this red histogram is based on, and I can change any of these. I can even select non-contiguous wells, although this doesn't actually make sense for this data because of the plating scheme, but just to show you that that's there, and that's with the heat map functionality. Okay, so this is kind of a complicated layout, but you can do a Z-score based on a very simple layout. You don't have to set up a full plate assay to start evaluating the suitability of your conditions for scale up. Okay, so I believe I have taken up pretty much our allotted time here. So thank you so much for your attention and your interest during this hour today. I hope we've shown you that if you just spend 15, 20, or even 25 minutes, if it's a very complicated layout setting it up, that there's a lot of power to your analysis, because the results are going to update live as you move your gates around, and that way you're not just blindly exporting results that you're going to show to your supervisor later, and he or she is going to say, you know what, that's not correct. You need to throw that away and start over with your gates. So if you had that situation, you would essentially have to redo everything. But doing it in FCS Express will save you a lot of time. And I see a question, can the Z-score be used with non-multi-well samples in essentially the same way? Absolutely, yes it can. Since all of those results, all of those are tokens here. You see, this is just based, I just clicked on one of the component tokens in the Z prime formula. It's just based on a particular plot. So as long as you've got a plot showing the stat that you want that component to be based off of, you can insert that into the formula. Absolutely. Okay, any questions about the Z prime or the t-tests? Trying to find my summary here. Okay, so thanks again. I'm going to stick around for a few minutes in case more questions come up. But for those of you who need to leave right on the hour, we hope we'll see you again at a future webinar. And thanks so much. Any questions? I'm still here in case anyone has any questions. I do see a few coming through the chat window. If any of those are widely applicable, I'll just answer them verbally. All right, everyone. Thanks so much. We'll see you next time. Have a great afternoon.